Hi everyone, I'm Kento Nakahoshi from Japan.
I'm Kurokawa. I'm in charge of a part of this presentation.
Thank you for giving us a chance to give a presentation here. Today, I would like to share with you our work in urban planning and modeling. Firstly, about the background. Japan is currently facing serious issues associated with an aging society and negative population growth. Constellation of urban structure is becoming more important, and various efforts have been made for visualizing urban planning in the last decade. This is the structure of IUR. The IUR is composed of 3D visualization tools, data encoding specification, and capacity building to promote data distribution regarding urban revitalization. This infrastructure enables municipalities to utilize the data which has been thrown into the cabinet. Now, I will explain the main functions of the 3D visualization tools that have been used for studying urban planning in Japan for 10 years. These are generally used in Japanese city planning and are the basis of city-GML urban planning ADE, which will be explained later. So I will show you some examples. First is time series visualization. A good point on statistical data is that the data is collected regularly, like every 5 or 10 years. Now, this movie shows the population change over time in the last 50 years. The color and height show the population. Also, a red and high grid means a large population. Finding these changes over time are very useful for future city planning. Next is cross visualization. 3D visualization allows us to see a couple of different statistics data at the same time. In this movie, the height of each grid shows population, and colors show accessible public transportation. In this city, large population grids are the same as the grids of high accessibility of public transportation. So we can say that the urban plan of this city worked well. There are many choices to combine a couple of data on the 3D map. Here is a final example of statistical data visualization. Like that, we can go through on a global level, national level, regional level, city level, and of course building level. It's very useful in urban planning to view everything together seamlessly. This was the origin of the proposal for the CityGML LOD extension presented in this paper.
In this paper, we developed the Urban Planning ADE. The basic survey of city planning is conducted by municipalities in Japan. However, it was difficult to reuse survey data. So, standardized data format is necessary for improving data reusability. In conceptual modeling, all items in the survey are divided into two components. The items not defined in CityGML are categorized into four subcomponents. Grid statistics are often applied on a national or worldwide level. However, the LODs defined in CityGML do not cover such a rough description. So, we extend LODs for describing global models. This figure shows the structure of LODs with a global model of LOD-1 and -2. The global model enables using 3D city models in policymaking phases and allows us to store and share all the information necessary in policy cycle into 3D city models. We developed a conceptual schema using UML. All objects defined in this model extend existing CGML objects without inconsistency. As an encoding format, GML schema is exported from the conceptual schema. In future works, we should consider an extension of the ADE and harmonization with CGML 3.0. Here is the progress of urban planning ADE so far. The ADE in this paper was published as IUR 1.1. The latest version, IUR 1.4, published in this March, extends the public transit network module. And we are now preparing for IUR 2.0.
Okay, in this way, IUR is constantly evolving by integrating user opinions. Then we developed the AR consensus formation system so that we investigate the IUR application. To increase citizen participation in urban planning, it's important to develop visualization tools that integrate available data with advanced technologies that account for IUR and its underlying CityZML feature semantics. It has two technical features. First, reproducing the massive quantity of geospatial datasets of a city from CityZML and Urban Planning ADE. Second, landscape simulation functions synchronized on AR glasses sharing the same geospatial data among a large group of people. We tested this prototype using CityZML data from several Japanese cities. The person in charge of urban planning in several Japanese municipalities utilized this system, and we confirmed that the implementation of AR technology could considerably affect problem solving in the field of urban development. Like that, AR city model allows multiple people to share same spatial data with AR glasses. So they can also switch some alternative or pinch model objects each other. This slide explains the concept of our efforts. We are hoping to push forward a positive and beneficial cycle. This can be described as a positive feedback loop that allows for a continuous growth in data resources. Let's start with the Aerocycle on the upper right. There is much motivation to visualize and evaluate urban features in detail. So then, data collection methods will be developed by every sector. These new data collection and visualization methods will allow us to more closely find out issues concerning urban structure. However, it shouldn't end there. From the new insights we've acquired, we can find more opportunities to organize and visualize. While repeating these steps for better urban planning, a vision for how the region's urban structure should be in the future will take shape. And there are over 100 of local governments challenging this positive cycle. For IUR to be used effectively, it is necessary for the actor involved in urban planning to work on it. So please watch a video about their efforts.
It's critically important that we always have that same fundamental concept of how we describe the shape of things and how they're placed on the earth, because that is the fundamental aspect of interoperability.
And these objects are subdivided according to semantic considerations. How to decompose a city into pieces and objects. That's basically the key element.
ここが都市計画道路が 1.1%、課題が多いんですけど整備効果が高いので早期に事業化する必要があるっていうのが見えてきました。
どこの場所にどんな緑が必要か、本当に3D の方が伝わるなと。
住民の方が今までにない反応をしていただいた。
Everybody can also browse and see the data, and they should also be able to send comments.
仙台都心地域の経済活動の状況を東京の都心と比較すること。
Value of the combination, I think.
企業系の人たちも自分たちの持っているデータと都市の外区のデータを少しマッチングしたりとか、
情報のハブにしたいっていうのを
周辺に対しても気遣ってくれてすごいですね。
Arigato, a very good presentation.
In this work, we conducted conceptual modeling and development of CityZML Urban Planning ADE, its implementation and visualization experiments and promotion activities. In the future, we will continue to work on the sophistication of Japan's urban policies together with the CityZML community over the world. That brings me to the end of my presentation. Thank you for your attention.